We have X being the SAT math score for science and engineering majors, and we're told they're normally distributed with a mean of 609 and a standard deviation of 80. We're asked in Part A what proportion of SAT scores should be under 569. So our first step is to take our value of 569 and get a z-score from that. So we'll take 569, we subtract the mean of 609, and we divide by the standard deviation of 80. That will produce our z-score of negative 0.5. What we're interested in then, picture-wise, is being under a z-score of negative 0.5. So when we have a z-score, we're centered at 0. So we have this value here, negative 0.5, and we want this area to the left. So you can go to that website that I have in the notes, and what you'll do is make sure the first bubble is selected, which is I want an area from a value. We'll keep the mean and standard deviation as 0, 1. Once we have a z-score, that's what we have. Then we just pick, are we doing above, below, between, or outside? We wanted the area below. You can see it shaded the graph to the left. And then we put in our z-score that we had just calculated, which was negative 0.5. And if we click then recalculate, we get a area or probability of 0.3085. And you can see that the picture here matches what we had drawn. Okay, so our answer here is 0.3085 for that probability or proportion. If we're looking at the probability, randomly selected student has an SAT score of at least 684. At least is a greater than statement or more than. So we find a z-score again, take the score, subtract the mean of 609, divide by the standard deviation of 80. We will get a z-score of 0.9375. So this time we're looking at the area to the right of this number 0.9375 because we are doing at least. Okay, so if we go back to the website again and we will switch to above, and then we want our value of 0.9375, recalculate, we get an area of 0.1743. And then the last piece, we're looking between the numbers 500 and 630. What you want to do is convert both of those separately to a z-score. So take 500, subtract the mean of 609, divide by 80, and we get negative 1.3625. Do the same with the other number. 630 minus the mean, divided by the standard deviation, and we get 0.2625. So we are, picture-wise, centered at 0, and we're looking between negative 1.3625 and positive 0.2625, and we want to know that area in between them. Okay, so if we go back to that website again, we will select between and then put in the two values that we're interested in. So we had a negative 1.3625 and a positive 0.2625. And we can see it recalculate then, and we get an area of 0.517. So that is the answer for that part C.